Namaste dear students, hope all of you are well. Today we are going to discuss ionic equilibrium. First of all, introduction. You know very well in class 10 we have studied about acid base, right? And we have discussed the properties of acid, the properties of base. And similarly we have read about the theories of acid and base also in GSEB board syllabus was there. In acid base chapter we have studied about Arrhenius acid, Arrhenius base, Lowry-Bronsted acid and base. Similarly, the same thing we are going to discuss in this chapter also. So no need to worry. Let's start. First of all, introduction. The earliest classification of substance into acid and base was based upon the characteristics, properties possessed by each one of them. For example, this thing we have studied in the earlier classes also, that how this acid and base was divided, right? So here you can see very easily that you can also say that acid was defined as a substance whose aqueous solution possesses the following characteristics property, means a substance which can conduct electricity, a substance which reacts with active metal like zinc, magnesium to liberate hydrogen gas, and a substance which turns blue litmus to red, a substance which has a sour in taste, a substance whose acidic properties disappear on the reaction with a base. So these were the properties of acid. This thing we have studied from the junior classes, right? Similarly, we have discussed about the base also. Base was defined as a substance whose aqueous solution possesses the following characteristic properties, like a substance which can conduct electricity, a substance which reacts with active metal like zinc, magnesium, here there is a little bit suspense that when base reacts, only one metal give that hydrogen gases. Similarly, it turns red litmus to blue. It has a bitter in taste and whose basic properties are destroyed on reaction with an acid. So these were the properties of acid and base by which you can understand this is acid and this is base. So these all the things are called operational definitions, means by which you can classify that these substances are acid or base. To know that these substances are acid and base, by doing this type of properties or this type of classification, you can classify that this substance is acidic or this substance is basic. These all definitions of acid and bases are called operational definitions, as they are based on the certain properties or certain operations or certain tests to be performed on the substances. Whatever the characteristics we have read that can be performed according to the experimental. Now, these have been replaced by the conceptual definitions. Conceptual definitions means according to the theory of some of the scientists, which was observed by the behavior, which was based upon the structure and composition of the substances. You must know that why these theories were given, that because of these conceptual definitions, you can understand that this substance is acidic, this substance is basic. But when you go in the higher standard, at that time there is a need to understand that really these things are conceptual, that if you taste, if anything it is sour in taste, so you can say acid. If anything it is bitter in taste, you can say this is base. But to do experiment, you need some behavior, you need some structure, you need some composition of the substances by which you can differentiate that this is acid or this is base. So Arrhenius has given his concept in 1884 that according to this concept, those substances which produce free hydrogen ion in aqueous solution are called acid. Means the chemical species which dissociate hydrogen ion in aqueous solution. The chemical species which dissociate hydrogen ion in aqueous solution is called acid. Now you can understand why I have said this thing, because according to this you can understand that why there is a definitions, why this conceptual scientists have given these theories to understand that any chemical species which dissociate hydrogen ion in aqueous solution is called acid. You can take some of the acid like hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid, sulfurous acid, acetic acid. Many acids are there. You can take these acids, and as you put this acid into the aqueous solution, it will liberate hydrogen ion in aqueous solution. Means it will dissociate. It will not liberate, it will dissociate. As it dissociate hydrogen ion in aqueous solution, that is confirmed that this is acid, right? Similarly, the substances which produce free hydroxide ion in aqueous solution are called base. Means any chemical species which dissociate hydroxide ion in aqueous solution is called base. So according to Arrhenius concept, he has given that any species which dissociate hydrogen ion in aqueous solution is acid, and any chemical species which dissociate hydroxide ion in aqueous solution is called base. As for example, if you mix sodium hydroxide into the water, it dissociates sodium plus and OH minus. Barium hydroxide, barium 2 plus plus 2 OH minus. So these species, you can say that these species are base. Now tell me, what is the nature of water? The nature of water according to this concept, it is neutral. Why it is neutral? Because it dissociates both the things, and it is taking the chemical species to dissociate both the things. So that's why the water is neutral and it acts as a solvent. What is neutralization reaction? You know, those reactions in which acid and base react together to form water molecule are called neutralization reaction. Means a reaction in which acid and base both can be react to form water molecule is called neutralization reaction. As for example, if you are taking sodium hydroxide and hydrochloric acid, so sodium hydroxide and hydrochloric acid will be dissociated as sodium plus, hydroxide minus, hydrogen plus and chlorine minus. They will give you sodium chloride and water. So since it is giving the formation of water, H plus and OH minus will be formed as a water. So this reaction is neutralization reaction. Now there is one question, that acid and base's strength, it depends on what? How you can understand that acid is a strong acid or weak acid? So the concept of strength of acid and bases. This concept explains the strength of acid and bases depending upon the basic or basis of degree of ionization. How they are ionizing. For strong electrolytes, it is directly proportional to 100%, and for weak electrolytes, it's less than 100%. Means it is the strength of acid and bases. It will give you the information about which type of acid is that. It will depend upon the ionization, how they ionize. If they ionize quickly into the aqueous solution, then that is strong acid. If do not dissociate hydrogen ion quickly, or if it is dissociating very slowly, then it is a weak acid. Similarly here, it depends upon the basis of degree of ionization. How do they ionize? How do they turn into the ions? As they rapidly turns or they turn slowly, according to that you can say that is a strong electrolytes or weak electrolytes. Now what are the advantages? This concept explains the acid and bases practically to find out the pH, ionization constant, hydrolysis constant, heat of neutralization, and etc. And what are the disadvantages? It explains the behavior of acid and bases only in aqueous solvent. So as we have seen that what are the limitations, that it only show the behavior of acid and base in aqueous solution, not in the other solution. And the advantages is that it gives you the concept practically to find out the pH, ionization constant, and hydrolysis constant, and heat of neutralization. So this was our Arrhenius concept. Let's solve a problem according to this concept, that gaseous hydrogen chloride is a very poor conductor of electricity, but a solution of hydrogen chloride in water is a good conductor. This is due to the fact of what? Water is a good conductor of electricity. Hydrogen chloride ionizes into the water and converts into H plus and Cl minus. A gas cannot conduct electricity, but a liquid can conduct electricity. Hydrochloric acid does not obey Ohm's law, whereas the solution obey Ohm's law. So this was the first question. The second question is, which acid is following pair according to the Arrhenius concept? Arrhenius concept, now you can see here that HCl aqueous and HCl gas, acetic acid liquid and acetic acid aqueous. Now you tell me, means gaseous cannot be, gaseous cannot dissociate, but the aqueous hydrochloric acid, when they mix into the aqueous solution, they dissociate H plus and Cl minus. Similarly, that liquid will not but in the aqueous solution of acetic acid it will dissociate into the H plus and OH minus. So these are aqueous acids, or sorry, you can say that these are Arrhenius acid, and this can be clarified in the aqueous solution. Now we are moving toward the Bronsted-Lowry concept, which was given in 1923. According to this concept, it is based upon the exchange of proton. If I talk about the define of acid according to the Bronsted-Lowry, so according to this concept, the substance which have tendency to donate the proton ion by any method in any solvent are called acid. Means according to this concept, any substance which have a tendency to lose H plus ion or proton ion either in the solvent or in any acid, so they are called acid according to Lowry-Bronsted. This theory was given in 1923. So some are just I am talking about the neutral molecules: HCl, nitric acid, sulfuric acid, carbonic acid, H2S, hydrogen sulfide, acetic acid, phosphoric acid, etc. Now if I talk about the anions, means you can see here according to this concept, as I have said, that which have a tendency to dissociate H plus ion or proton ion, which have a tendency to donate proton ion, so they are called acids. So here you can see some anions, some cations. I talk about hydrochloric acid. If you mix hydrochloric acid into the water, that's H2O solvent, then H2O will take H plus from HCl and it will become H3O, that is called hydronium ion. So as you know very well, if any chemical species or any substance which have a tendency to donate proton, so HCl has a tendency to donate proton, HCl has donated its H plus ion to H2O and H2O became H3O plus, that is hydronium ion, so HCl is an acid. Similarly, HS minus will also dissociate H plus, so it will be converted into the H3O plus and S2 minus. If I talk about ammonium plus, now you just see that which has a tendency to gain H plus, or in the aqueous solution which have a tendency to donate H plus, they are acid, and which have a tendency to gain H plus, that are base. But here as you mix this NH4 into the aqueous solution in H2O solvent, then it will become NH3 and H3O plus, so NH4 plus is also acid. So here some confusion comes, ammonium ion is a base or acid. So here there was means you can say this was also limitations of Arrhenius. Now if I talk about AlH2O6, hexa aqua aluminum 3 plus ion, when you mix this thing into the solvent, then again they will convert into H3O plus, means it is losing H plus ion. So as it loses H plus ion, it becomes hydronium ion, so that is acid. So you must understand, according to the Bronsted-Lowry concept, that any substances which has a tendency to donate proton is called acid. And if I talk about the base, the substances which have tendency to accept the proton by any method in a solvent are called bases. Examples, as you can see, HS minus, HCCO3 minus, HSO4 minus, H2PO4 minus, HPO4 minus, O2 minus, SO4 minus, CO3 minus, Cl minus, Br minus, I minus, cyanide minus, etc. Means just remember which has a tendency, as HS minus will accept one electron and it will become H2S, right? Hydrogen sulfide. So a chemical species which has a tendency to accept proton by any method in any solvent, that's called base, according to the Lowry and Bronsted. Similarly, if I talk about the nature of water, so according to this concept, the nature of water is amphoteric or amphiprotic, a new word, amphiprotic. That is, water can act as both acid and base. Amphoteric means, you know very well, weak acid and weak base, but here amphiprotic, that is called water can act as a acid also, and because see H2O can be act as a H3O plus also, and H2O can remove OH minus also. So definitely water is having both the property of acid and base according to this concept. So you can see here that HCl plus H2O, it will give H3O plus and Cl minus, since here water is accepting H plus. And here you can see that if we take NH3 plus H2, it will gives you NH4 plus and OH, means again it is dissociating hydrogen ion, means it is losing the proton ion, so it acts as acid also and it acts as a base also. So that's why the nature of water is both amphiprotic and amphoteric. Okay, now the next one is neutralization reaction. According to this concept, those reactions in which acid and base react together and convert into the respective conjugate acid and conjugate base are called neutralization reactions. You can see the examples of conjugate acid and conjugate base in HCl and NH3. In HCl, H plus and Cl minus will be, and NH3 will take H plus, so it will become NH4 plus. So since NH3 is taking H plus ion, so it becomes conjugate acid, and HCl is dissociating, or it is donating H plus ion, so it will become conjugate base. Now the strength of acid and strength of base, according to the concept, the strength of acid and base depending upon the basis of relative tendency to accept or donate the proton. Means you can say here some of the examples are given, that how you can understand that these are having a tendency to accept proton or dissociate proton. So here you can see some of the examples. HCl plus H2, that is Cl minus and H3O plus, right? You can see here the strong acid plus strong base, strong acid plus strong base, that is weak base plus weak acid, right? In this equilibrium, why I'm showing you. But if you talk about in the neutralization reaction, strong acid and strong base will give you neutral salt and water, right? But here you can see strong acid and strong base. Here water I am acting as a strong base, okay? And if I talk about weak acid and weak base, then they will give you a strong base and strong acid. Weak base and weak acid, strong acid and strong base. Weak acid and weak base, strong base and strong acid. Strong acid and strong base, weak base and weak acid. Strong acid and strong base, weak base and weak acid. Some examples, you can see hydrochloric acid when treated with water, it gives Cl minus and H3O plus. Acetic acid is when treated with water, it gives CH3COO minus, that's called strong base, and H3O plus will be converted as a strong acid. Weak base, ammonia plus water, ammonium ion, that is strong acid, and OH minus is strong base. Similarly, here you can see HCl and acetic acid, Cl minus and CH3COOH2 plus. So here, as you can see, this how they are being converted into the strong acid and strong base. So let us remember some of the points which should be remembered. So you can see here points to be revised before finishing the concept. You must remember some of the points like protogenic or acidic solvent, they have a tendency to generate or donate the protons. Example, acetic acid, hydrochloric acid, nitric acid, sulfuric acid. Protophilic or basic solvent, they have a tendency to accept the protons like ammonia, methanol, primary amide. Amphiphotic or amphoteric solvent, they have a tendency to accept or donate the protons, or they are either protophilic or protogenic. Example, water, HS minus, HSO4 minus, HCO3 minus, etc. Aprotic solvents, they neither donate nor accept the protons. Benzene, carbon tetrachloride, CHCl3, BRF3, NO2, COCl2, etc. They do not accept or donate the protons. And some ampholyte solvent, those solvent which has the same molecule act as a proton donor and a proton acceptor, as amide, you can see glycine, that NH2, CH2, COH, and here NH3 plus, CH2 and CO minus. You can see that it has a tendency to act as a proton also, a proton donor also, and proton acceptor also. So this is a glycerine example, proton donor group. You can see in this sulfonylate acid here, proton donor and proton acceptor, you can see. So which are having both the tendency that are called ampholyte solvents. Some of the advantages: it explains the behavior of acid and bases in any type of solvent. It explains the stability of proton. And disadvantages: it does not explain the acid and base practically. It does not explain the acidic behavior of aprotic acid like sulfur dioxide, sulfur trioxide, carbon dioxide, ammonium trichloride, silicon tetrachloride, etc. Now the new concept is Lewis concept. Have you heard the word Lewis? You may have heard in the chemical bonding. Yes. So Lewis had given his concept in 1939. He has said, according to his concept, the species which have self-tendency to accept the lone pair of electrons are called acid, which can accept a lone pair acid, which can donate a lone pair base, according to the Lewis concept. Lewis acid is an electron pair acceptor. Lone pair acceptor is acid, that is also called electrophilic, like H plus and OH minus. You can see in OH minus H plus is acid, H minus is base, but here that it's called OH minus has a tendency to accept electron lone pair, or you can say pair of electrons. So it is an Lewis acid. If you classify the Lewis acid and Lewis base, you can see here BF3, BR3, BCl3, BI3, BCH3 all thrice, BOH all thrice, AlCl3, GeCl3, etc. These all are having a tendency to accept electron pair. So that's why they are Lewis acid. Compounds whose central atom has vacant d orbitals and can accept one or more pair of lone electrons. Means this is according to the coordination compound that which are having vacant d orbital. Central metal atom must have a vacant d orbital which can accept a pair of lone pair of electrons. So they are called Lewis acid. You can see SF6, IF5. Molecules with a multiple bond between atoms or different electronegativities, like carbon dioxide, sulfur dioxide, sulfur trioxide. So you can see the examples of Lewis acid and Lewis base. Cations and anions. Now in the cations you can say silver plus, sodium plus, lithium plus, aluminum 3 plus, beryllium 2 plus, magnesium 2 plus, iodine plus, Cl plus, H plus. These all are the Lewis acid. You can say they are having a tendency to accept a lone pair electron. False cation, ammonium plus, hydronium ion, CH3CO, H2 plus, PH4 plus. So these are false cations. These are not true cations. Means false cation means what you know, because NH4 has means it has became as a NH3 plus H, so it became NH4 plus, right? So elements which have 6 electrons in their outermost shell or valence shell. You can see that in the oxygen family, sulfur, selenium, tellurium, polonium is a radioactive element. So SO3 2 minus is a base and oxygen is a acid. So SO3O 2 minus will be the Lewis acid, right? Now if I talk about the Lewis base, those bases which have self tendency to donate the lone pair of electrons are called bases. Base is an electron pair, lone pair donor. So nucleophile is a base and electrophile is an acid according to Lewis, right? So classification of base, you can see the species whose central metal have lone pair of electrons and have self tendency to donate them. An element which have a self tendency to donate a lone pair of electron is called Lewis base. You can see ammonia, and the ammonia nitrogen can donate a lone pair of electron, right? Primary amide, secondary amide, benzene amide. You can see these all compounds, whatever it's represented at your screen, they are having a tendency to donate a lone pair of electrons. So they are Lewis bases, right? Electron density on oxygen increases due to the plus I effect, inductive effect, right? You can see some cations, and in the acid that were cations, and in base they are anions. O2 minus, SO4 2 minus, CO3 2 minus, Cl minus, Br minus, F minus, I minus, N3 minus, P3 minus, NO3 minus, S2 minus, Cl minus. So these are Lewis base. What is the nature of water? According to this concept, the nature of water is basic. Why they are basic? Because it has a tendency to accept a lone pair of electron. Sorry, it has the tendency to accept or donate. Remember the word. In Lewis base, if I talk about, then they are having a tendency to donate a lone pair of electrons. So they are Lewis base. And in chemical species which have a tendency to accept a lone pair of electrons, they are Lewis acid. Okay. Nature of water is Lewis base. Neutralization reaction, you can see here Lewis acid plus Lewis base. BF3 and NH3, when you react to this both, you can see from nitrogen side the electron pair is going towards the boron. So this is the neutralization reaction, because both according to this concept, Lewis acid and Lewis base, you can see what will happen here in NH3. Nitrogen has a lone pair which it can be donated, but here from BF3, since in ammonia they are accepting one electron, so it will become NH4 plus, and in water you know very well, as it accepts H plus, it will become hydronium ion. In silver, you know, as it accept the lone pair of electron from the ammonia, both the ammonia, so it becomes AgNH3 2 plus. Now the strength of acid and base according to this concept. What is the strength of acid and base? If I talk about the strength. So according to this concept of acid and base, it is depending upon the basis of self tendency to accept or donate lone pair of electrons. Accept or donate lone pair of electrons. Sulfur dioxide to sulfur trioxide, strong acid. Now if I talk about the advantages, this concept explains the acid and base without any solvent. This concept explains those acid and bases which are not explained by the other concept. And disadvantages, this concept fails to explain the acid and base practically. According to this concept, the forming of coordinate bond is neutralization reaction of acid and base, as it is a slow process, whereas neutralization reaction of acid and base is actually a very fast process. This concept fails to explain the real acid and real base like hydrochloric acid, nitric acid, sulfuric acid, sodium hydroxide, potassium hydroxide. All the Lewis bases are Bronsted bases, but all the Lewis acid are not Bronsted acid. Yeah, that's true. All Arrhenius acid and Bronsted acid are Lewis acid, but it is not so far for bases. So this was the similarities and difference between the Arrhenius, Lowry and Lewis concept. Hope all of you have understand about this concept. If you have any doubt related to this concept, then you can drop your doubt into the comment box section. That's all for today. Thank you very much. If you have not liked and subscribed the channel, then don't forget to like and subscribe the channel. That's all for today. Thank you very much.